Did you know that SLS 3D printers can produce end-use quality, flexible parts with variable durometers? TPU, or thermoplastic polyurethane, is a commonly used industrial elastomer relied upon across a wide range of industries, including manufacturing, automotive, sporting goods, packaging, and drones, for its flexibility and cushioning properties. In this video, we'll showcase Formlabs TPU 90A powder for the Fuse Series SLS 3D printers. We'll cover the applications and use cases, material properties, how to achieve variable durometer parts, and show some real-life examples. TPU parts are everywhere around us, from the cases that protect our phones, to the gaskets, hoses, and fuel lines that keep our cars running. These mass-produced TPU consumer products are typically manufactured with injection molding. However, as 3D printing hardware and material science have advanced, 3D printed TPU is becoming more popular for its design freedom, customizability, and end-use durability. While some types of 3D printing technologies, like resin printers, create formulations that approximate the mechanical properties of TPU, FDM and SLS 3D printers offer the real deal, TPU filament or powder. 3D printing TPU offers several benefits that injection molded TPU cannot. It enables a shorter, iterative product development cycle. It enables cost-effective customization, especially in industries where customization adds a premium. And it increases geometric flexibility, allowing designs that are impossible with traditional tooling, like complex lattices or internal channels. To 3D print TPU, you can use fuse deposition modeling, or FDM, or selective laser sintering, or SLS, 3D printers. FDM printers use TPU filament extruded layer by layer. This is the most affordable option, but it has some limitations. FDM TPU parts are anisotropic, meaning layers are not chemically bonded, and mechanical properties vary depending on load direction. This can cause delamination or fluid absorption, which is problematic for TPU parts like hoses, gaskets, or seals. By contrast, SLS 3D printers fuse TPU powder particles in all directions to form the final part. As a result, SLS TPU parts are strong in every direction and better suited for end-use applications. Today, 3D printed TPU parts are used across industries, from consumer goods prototyping, to manufacturing aids, to fully customized products. Traditionally, prototyping elastomeric materials was limited, time-consuming, and often messy. Designers either sent out for tooling, which was costly and slow, or made their own molds, a labor-intensive and often unreliable process. 3D printed TPU allows designers to test new ideas multiple times a day, using the same material they'll eventually use for mass production. At RadioFlyer, the product development team uses TPU 90A powder on the Fuse 1 Plus 30-watt printer to rapidly iterate soft components that will eventually be injection molded rubber, like soft grip handlebars. Footwear is another major opportunity for SLS 3D printed TPU. Prototyping insoles and midsoles with varying durometers is faster and easier than traditional manual mold making methods. 3D printed TPU also benefits factories that require on-demand manufacturing aids. TPU components can extend the lifetime of heavy machinery in systems that experience high wear or friction. Custom bumpers, cable guides, enclosures, and mounts can be designed, printed, and replaced as needed, helping factories reduce costs and maintain uptime. At Heidelberg, SLS 3D printed TPU manufacturing aids extend the life of machinery components used in large printing presses and automation systems. This TPU 90A powder cable guide protects complex robot wiring from friction and wear. SLS 3D printed TPU delivers the ideal combination of geometric freedom, friction resistance, and flexibility. At Deutsche Bahn, Germany's national train operator, 3D printed TPU bumpers and covers protect train components during maintenance, repair, and overhaul operations. SLS 3D printed TPU parts are durable enough for end-use applications, and the self-supporting powder bed enables complex lattice structures. For low-volume or customization-heavy industries, such as drone manufacturing, SLS 3D printed TPU reduces time to market as well as overall costs. In healthcare, Skin-safe TPU enables customization of prostheses and orthoses. Arion prints its end-use device, the Eris, in TPU 90A powder on the Fuse Series. When SLS printing TPU on the Formlabs Fuse Series, users can even adjust durometer using Preform's print settings editor. Parts can be printed with verified settings at 90A, 80A, 60A, and 50A shore hardness, all without changing the printer or the material. 3D printing TPU doesn't just replicate traditional manufacturing, it enables new possibilities for rapid development, customization, and efficiency. SLS 3D printers, like the Formlabs Fuse Series, offer an affordable way to produce highly complex TPU parts. To see the quality of SLS 3D printed TPU for yourself, request a sample at the link in the description.